about density chapter and the numericals concerned with that. This is basically meant for class 7 and 8 who find lot of problems in solving the questions of density, right? So first of all, when we speak of density, we know that density means arrangement of molecules, right? If you consider a solid state of matter, okay, the molecules are closely packed, okay, and in case of liquid, the molecules are little bit far apart, okay. This is the arrangement of molecules in liquid state, and in gaseous state the molecules are too far apart. This is the arrangement of molecules in gas. So we can compare the density of solid, which is more compared to the liquid. This is the density of solid, this is the density of liquid, and this is the density of a gas. So if you look at this particular comparison, the solid is having maximum density. So density means arrangement of molecules. How the molecules are closely spaced or far apart, that depends, that affects the density of a substance, okay. Now let's come to the formula, but before that let us define density. Density is defined as the ratio of mass of a substance to the volume, okay. So here we have the expression for density, which is ratio of mass per volume, and if you want to express mass, then cross multiply these two, we get the expression volume into density. If you want to find the volume, then divide the mass by density, okay. This is the first expression, this is the second expression, this is the third expression. Now we can also express volume as area into length or area into height, okay. Fifth expression, we can also express volume as the product of length, breadth and height, okay. Well, this is for a solid which is cuboid shaped. This is the cuboid, okay, which is a regular bodies. Here the length is this one, breadth is this one, height is this one, okay. This is for regular body, that is for cuboid. Similarly, if you want to calculate the volume of a cylinder is represented like this. So if this is the radius of the cylinder, okay, this is the height of the cylinder, then we can apply the formula for the whole volume. This is the volume of cylinder, which is pi r square h, okay. Similarly, for a cone, okay, which is just like a birthday cap, this is the height of the cone, this is the radius of the cone. So for volume of cone, we can have the formula 1/3 multiplied by pi r square h. So there are several regular shaped bodies, you can find them by formulas, and these formulas are only possible because you can measure the dimensions, length, breadth, height, radius, okay. Similarly, for a cube, okay, we have the volume, this is sides, all sides are equal for a cube, you know. So volume of cube, this is equals to side cube, okay. So we must know the dimensions to find the volume of regular bodies. Now how to calculate the volume of irregular object. Irregular object means, just like we can take the example of a stone. Okay, this is a stone whose volume you have to find out. Now this volume of this particular irregular object can be found or calculated by displacement method. Now what is this displacement method? We are going to take a jar, cylindrical jar having graduations. That means you can record the volume of the liquid. Suppose initially the volume of the liquid in the beaker was x ml. Ml means milliliter. Now with the help of a thread, gradually insert into this liquid this particular stone. This is by means of a thread we are inserting this particular stone. Okay, so the stone will occupy volume inside the liquid. Definitely the level of the liquid will rise. Suppose this final volume is y ml from here to here. This is the initial level of the liquid up to x, that is from here to here. This is the final volume. Now volume of stone can be estimated by finding the difference of these two, that is final volume minus initial volume. Okay, that comes to y minus x ml. Because 1 ml is same as 1 centimeter cube, you can also write y minus x centimeter cube. Now let's come to the units. How do you decide the units? Okay, suppose this is a quantity, the physical quantity. Okay, this is the CGS unit. CGS means centimeter gram second. Then we have the MKS unit. MKS means M stands for meter, K stands for kilogram, S stands for seconds. Suppose in this we are going to take the unit of mass, then that will be in grams in CGS system, kg in MKS system. Next comes the volume. We have centimeter cube for this and meter cube for this. Okay, then we come to density. Okay, applying this formula, density equal to mass by volume, keeping the mass in the numerator, volume in the centimeter cube. In denominator we have gram per centimeter cube. Okay, and for this we have kg per meter cube. Okay, you can change kg per meter cube to gram per cm cube or vice versa. Okay, the conversion is gram per cm cube. If you multiply by 1000, you get the density in kg per meter cube. Okay, this is the density. Okay, so having known the density in gram per cm cube, okay, you can convert that into kg per meter cube by multiplying this with 1000. Similarly, if you want to convert kg per meter cube into this density in kg per meter cube, if you divide it by 1000, you get the density in gram per centimeter cube. Okay, so these are the conversions you need when you are discussing the questions. Suppose if I give you volume in centimeter cube, density in kg per meter cube, you have to find the mass. Before applying the formula, please convert kg per meter cube into gram per cm cube, right? So that the units become homogeneous. That means the volume given in centimeter cube, density in gram per cm cube, definitely the mass comes in grams. Suppose if I give you volume in meter cube, density in gram per cm cube, please convert this into this, applying this formula. After knowing it in kg per meter cube density, volume in meter cube, then you can find the unit of mass, that is in kg. Okay, so I think the formulas are very clear. Now you have to practice, keeping in mind the conversions, which are very important, right? Thank you.